Hello friends, welcome to GT Science tutorial. In this video, I am going to explain about the ionic or electrovalent bond or compound, the factors affecting the formation of ionic bond and the properties of ionic compounds. In my previous video, I have already explained what bond is. Bond is the force of attraction that keeps the atoms of same or different elements together. And there are three types of bonds, and among them, one of the very important bond is ionic bond. So in this video, we will understand everything about ionic bond. So let's start. There are three types of bonds. They are ionic or electrovalent bond, covalent bond and coordinate covalent bond. And among them, this ionic or electrovalent bond is very important to understand. This bond is formed by complete transference of electron from the outermost shell of one atom to another atom. Let me write the definition of it. The bond formed by complete transference of one or more electrons from one atom to another is called ionic or electrovalent bond. So in this, to form this bond, an atom must lose some electron and another atom must gain some electron. The atom that loses electron forms cation. And generally metals lose electron. They have high tendency to lose the electron. Similarly, the atom that gains electron forms anion, generally non-metals. Generally, the metals loses the electrons and the non-metals gain the electron. So this is what happens while forming the ionic bond. Ionic, you can see, or you can understand the meaning from the word itself. There will be the formation of ions, that means cations and anions, and you can easily know which one is positive ion and which one is negative ion. Here, let me tell you a trick. Okay, this is N means negative ion, or negative ion means anion, that is it should have minus charge. That means that atom will gain some electron. And similarly, cation, this T looks like a plus sign, right? Or remove this C, okay? Or positive, this looks like a positive sign. Positive ion is called cation. That means the atom will have plus sign. That means it loses the electron. Let us take the example of MgO, magnesium oxide. Okay, let's take the example of magnesium oxide formation. Let's see what actually happens over here. If we see the electronic configuration of magnesium, of magnesium is equal to 282. Magnesium has 12 electrons. That means its atomic number is 12. So its electronic configuration is 282. And electronic configuration of oxygen is 26. Now, to be in octet state, that means to be stable, the atoms or the elements must have octet or duplet state. So they tend to be in octet state. What will they do? To be in octet state, either the element or the atom loses electron or gain electron. Okay, it's not like money case that always gaining is a profit. No, they will try to be stable. For that, either they will lose the electron or gain the electron, doesn't matter. So octet means there should be 8 electrons in its outermost orbital. Octet resembles or comes from the Sanskrit word at, okay, at or oster, you can say that. Now look at here. To be in octet state, magnesium needs to lose these 2 electrons, then it will have 8 electrons in its outermost orbital, and oxygen needs to gain 2 electrons, then finally it will have 8 electrons in total in its outermost orbital. So in this phenomenon, what will happen? Magnesium will actually lose 2 electrons and it will form Mg2 plus ions like this. And similarly, oxygen will actually gain 2 electrons and it will form O2 minus. Are you getting me? Here you can see this magnesium is a metal, it is losing the electrons. I've written it over here. Metals generally lose the electrons, and oxygen is a non-metal, it is a gas and it gains the electron, it is gaining the electron. And if we just add them, we will get magnesium plus oxygen forms magnesium oxide. So you can see over here, this is how the reaction happens. Actually, magnesium is transferring its 2 electrons to the oxygen, and that's how the bond formed. So we can say that the bond formed by complete transference of one or more electrons from one atom to another atom is called ionic or electrovalent bond. This is a very strong bond, okay. This is the strongest bond, you can say. Now as bond is being formed, how does the bond form and what is the direction of the bond? Look at here. Here there is Mg2 plus and there is O2 minus. These are ions, right? These are ions and they have charge over here, and if there is charge, then obviously they are pulling each other by electrostatic force of attraction, okay. Net electrostatic force of attraction is making them pull each other. They are coming closer and closer and closer, and finally they will make a bond. So there is electrostatic force of attraction between them, and you can see over here, this is Mg2 plus, this is O2 minus, right? Mg2 plus is a charged ion, then obviously it has a electrostatic field like this, some kind of field over here. Oxygen also has charge, so it will also have some kind of field over here. If they both come in contact with each other, that means if this magnesium ion come in the field of oxygen or oxygen come in the field of magnesium, then they will start to pull each other and they will form a bond. They will form a bond. It doesn't specify which direction it will be formed in. So we can say that ionic bond is a non-directional bond. It does not have any direction. Okay, it does not have any direction. So let me write it over here. Ionic bonds are non-directional. So there is no direction of the ionic bond. Okay, it can form from any side. So this is what ionic or electrovalent bond is. Now let's see some factors that affect the formation of ionic bond. As ionic bond is formed by the complete transference of electron from one atom to another atom, then obviously it is affected by different factors. In this video, I am going to explain the 4 different factors that affects the formation of ionic bond. They are ionization energy, electronegativity, electron affinity, and lattice energy. So let's understand one by one. The first one is ionization energy. So how does ionization energy affects the formation of ionic bond? Let's see that. So we know that to form ionic bond, obviously the atoms should be converted into ions, right? There has to be some charge over there. Without the charge, they will not come closer and there won't be any force of attraction between them. So to form ionic bond, there has to be charge. Now let us consider sodium Na. For our example, okay, sodium has 11 electrons. So its electronic configuration is 281. Now to be in stable state, so obviously it will lose this electron, and if it loses one electron, then it will convert to Na plus, right? And it will have 2,8 electronic configuration. Now to form this Na plus, it has to lose one electron, and we know that to remove the electron, we have to supply some energy. Are you getting me? We have to supply some energy to convert this metal into metal ion. We have to supply some energy. Now just imagine if we have to supply more amount of energy to remove one electron, then will the bond form be stronger, or will the bond form easily? No, not at all. It will try to find the simple way. If we provide very small amount of energy or no energy at all, or if it gets the energy from the light or natural source, or even if we have to supply very small amount of energy, then it will prefer that way, right? So we can say that ionization energy affects the formation of ionic bond. That is true. But if the ionization energy is less, then the bond will form more easily. Can we say that? If the ionization energy is less, then the bond will, that is ionic bond, will form faster. So let me write it over here. Less value of ionization energy favors the formation of ionic bond. Less value of ionization energy favors the formation of ionic bond. This is generally for metal case. Now for non-metal case, 2 number, there is electron affinity. Now to remove the outermost electron, we need to supply energy. Now if we need to put one extra electron, then energy will be released from there. Are you getting me? This is very simple concept, okay? If we want to remove the electron from the outermost orbital of any atom, we need to supply some energy. But if we are adding an electron to the outermost orbital of any atom, then it will release some energy. Now if it loses or if it releases more amount of energy, then obviously that ion will be stable and bond will form easily. So are you getting me? If the energy released by the atom while forming the anion is very high, it is losing energy, then it will be more stable. It does not try to contain more energy. They try to lose energy. And if it loses more energy, then obviously the ion will be stable and the bond will form faster, right? So let me write it over here. Higher value of electron affinity favors the formation of ionic bond. Okay, now this is for non-metal case. Non-metal, because non-metals generally form anion. So these are the 2 different factors. Now let's see the third one. The third one is lattice energy. You know the meaning of lattice energy? Lattice energy is the amount of energy required to break 1 mole of ionic compound into different ions. Let me write the definition of it, okay? Lattice energy is the amount of energy required to break down 1 mole of ionic compound into different ions. So if we have 1 mole of ionic compound and if we want to break it by providing some energy, then the amount of energy provided to the ionic compound to break it into different ion, that is cation and anion, is called the lattice energy. Now just imagine, if the bond breaks very easily with less amount of energy, then will that be stable? Will the ions try to form that type of bond? No. If we want to make a home, then obviously we will make a very strong home, right? The foundation will be strong so that it will last for ages. The same thing happens for the bond. They will not try to form very weak bond. They will try to form strong bond. Now, if the bond breaks with less amount of energy, they will not try to make that, right? So higher value of lattice energy. That means if it requires more amount of energy to break a single bond, then obviously that bond is stable, right? Because that bond is very strong. That's why we are providing more amount of energy. So we can say that higher value of lattice energy favors the formation of ionic bond. This is very simple, right? Now finally the last one is the electronegativity. Now the fourth one is electronegativity. Electronegativity. Do you know the meaning of electronegativity? Electronegativity is the tendency of an element to attract the electron pair towards itself. If the if the anion is pulling electron with a greater force, then obviously the cation will not have any problem losing the electron. That's why if the electronegativity difference between different atoms is very high, then that favors the formation of ionic bond. Let me write it over here. If the electronegativity difference is more than 2.1, it is considered to be 2.1, then it favors the formation of ionic bond. Sometimes it is also taken to be 1.9. In some book you might find the value of electronegativity difference should be 1.9 or 2.1. okay, somewhere you will find 1.9, somewhere you will find 2.1. So these are the four different factors that we just read: electronegativity, ionization energy, electron affinity, and lattice energy. They actually affects the formation of the ionic bond. I hope you understood everything about it. Now let's see the properties of ionic compound. There are many properties of an ionic compound, and in this video we are going to see some of the important properties of ionic compounds. Let's see them one by one. The first one is physical state. So what is the physical state of ionic compound? If you notice one thing, all the ionic compounds are found in crystalline form. If you see the salt, that is also in crystalline form, right? All the ionic compounds are found in crystalline form. That is shown by the X-ray technique. The X-ray diffraction technique actually showed all the ionic compounds exist in ionic form. Let me write it over here, then we will understand why that happens. Okay, all the ionic compounds are found in crystalline form. That is shown by X-ray technique. And there is no any exceptional. There is not even a single ionic compound that is found in either liquid or gaseous state. Okay, there is a reason for that. As the ionic compounds are formed by positive and negative ion, then obviously their electrostatic force of interaction results in the force of attraction, right? They will try to come closer. Positive and negative ion will try to come closer and closer and closer. Okay, and this electrostatic force of interaction actually makes it very dense. And another thing is they actually make a very good lattice, their lattice site. Okay, like look at here, there is positive, there is negative, then obviously with this positive there has to be another negative, with this negative there has to be another positive, then they are arranged very nicely, very properly. Okay, that is like the crystalline form. That's why the physical state of all the ionic compounds is always crystalline form. There is no any ionic compound that is found in other form, that is gaseous or liquid state. Ionic compounds are not found in gaseous or liquid state. liquid state. So the physical state is this. All the ionic compounds is found always in crystalline form. Okay, and there is no any exceptional cases for this. Now let's see the second one, that is the melting point and boiling point. Boiling point, we know that ionic bonds are very strong. Okay, ionic bonds are very strong. The positive and negative ion will come very close and they will try to grab each other with that bond, and to melt it we must mobilize the ion, right? Because in solid the molecules are very close to each other like this. In liquid they are little farther from each other. In gas they are very far from each other, that is interionic distance, intermolecular distance, right? So in solid, in crystalline form, the atoms, the ions are like this. Now we need to mobilize it. Now to mobilize it, we need to provide some energy. Now as the bond is very strong, then we need to provide a large amount of energy in order to mobilize the ion and convert it into the liquid. That means the melting point of ionic compounds is very high. And similarly, if we want to mobilize the ions even more to convert it into gas, then we need to provide more amount of energy, even more than the melting point energy, right? So let me write it over here. The melting point and boiling point of ionic compound is extremely high due to the strong bond. Okay, the melting point and the boiling point is extremely high. Now it actually varies with different cases. Look at here, high charge on ions and small nuclei increases the melting point and boiling point. So the value of melting point and boiling point increases if the charges on the ions is very high and the size of nuclei are very small. There is a reason for that. If the charges of the ions is very high, then they will try to grab each other with greater force of attraction. Okay, the bond will be even more stronger. And if the size of the nuclei is very small, then also they will grab each other with very strong force, and it's difficult for us to mobilize the ions. So this is what happens. Okay, the melting point and boiling point of ionic compound is very high. You can see the chart over here. Look at the difference. Okay, they are very high values. Now let's see the third property, that is the electrical conductivity. Okay, I can write it over here. Electrical conductivity. Electrical conductivity. As we know that the ionic compounds are formed by positive and negative ion. They will be like this, minus, plus, and so on. And there is very strong force of attraction between them. Now to conduct electricity, obviously the ions has to move from one lattice side to another lattice side, but due to this strong force of attraction they won't be able to move. So will it conduct electricity? What do you think? No, not at all. It will not conduct electricity because they are held by very strong force of attraction that does not allow to move, that does not allow the ions to migrate. That's why the electricity will not flow. Or we can say that it's in solid state or in crystalline form, the ionic compounds are very bad conductor of electricity. Let me write it over here. Bad conductor in case of solid or crystal form, but it becomes very good conductor of electricity in molten form or in liquid form. So good conductor of electricity in liquid form. There is a reason for that. When it converts into liquid, the ions can now mobilize easily. The ions move separately, right? They are very far from each other, and it is full of ions. And we know that if ions can move, it can conduct electricity as well, right? It can migrate. That's why it can conduct electricity. So in liquid form, the ionic compound become very good conductor of electricity. Now let's see the fourth property. For that, let me erase this portion. The fourth and very important property of ionic compound is solubility. This property is very important for your examination as well. We know that ionic compounds are soluble in polar solvents like water, but it is insoluble in non-polar solvent like organic solvent like benzene or ether or chloroform. First of all, let me write that and I will tell you why it happens. Ionic compounds are soluble in polar solvents like water and they are insoluble in non-polar solvents like benzene, ether, chloroform, etc. So what is the reason for this? See, we know that water has the highest value of dielectric constant, and that can break this ionic compound, and the organic compounds do not have very high value of dielectric constant, so that cannot break this ionic compound. Now getting confused by this term that dielectric constant, so let's try to understand this in another way as well, that is in the form of solvation energy. That is even more easier than this. Now solvation energy, when we put some ions in some polar solvent or non-polar solvent, then a kind of interaction happen over there and some kind of energy is released. Let me tell you how it happens. Suppose we have an ionic compound, that is Mx. M means metal, X means halogen. So metal has positive charge and halogen has negative charge. And if you put it in water, H2O, then what will happen? We know that water is a polar compound. That means O will have minus and H will have plus charge, delta minus and delta plus, that is partial negative, partial positive charge. And there will be an interaction. What will happen? This positive ion of this ionic compound will be surrounded by the negative terminal, and this negative ion will be surrounded by the positive terminal of this solvent. In place of water, there could be other solvent as well. Then what happens? There will be M plus over here, and as this is the cation, then obviously negative terminal should be closer to it. So oxygen will be closer to it and hydrogen will be far from it. It will be like this. The water molecules will surround it like this. Water molecules will surround it like this. There is minus, plus, minus, okay, plus. Now X minus, there is an ion as well, and in water there is positive terminal as well. So this will be surrounded by the positive terminal of water and negative terminal will be farther from it. So H and H will be closer and oxygen will be very far from it. And here also H and H will be closer and oxygen will be very far from it. H and H will be closer and oxygen will be very far from it. Minus, minus, minus. Delta plus, delta plus, delta plus, delta plus, delta plus, delta plus. I hope you understood it. Now there has been an interaction between the ions of this ionic compound and the polar solvent. Now during this interaction, some energy is released. That energy is called solvation energy. Solvation energy. So I hope you understood it properly. So during the interaction of the ionic compound and the solvent, some energy is released like this, and that energy is called the solvation energy. Now that energy is being released. Now we know that in ionic compound there is a ionic compound can be broken by lattice energy, right? We need to provide some energy. If that energy exceeds the lattice energy, then obviously if that energy exceeds the actual lattice energy of this ionic compound, then this ionic compound will be broken, and here in that case that providing energy will be solvation energy, and that is formed by this interaction. So we can say that if the solvation energy is greater than the lattice energy of this ionic compound, then this ionic compound will be broken and this will be soluble. So if solvation energy is greater than the lattice energy is greater than the lattice energy, then it will be soluble. And if solvation energy is less than the lattice energy, then it will be insoluble. Now for this case we can consider M plus X minus plus C6H6. What is this? This is benzene. Non-polar. Then obviously there won't be any solvation phenomenon over here, no solvation, and as a result of that there won't be any solvation energy as well. And if there is no solvation energy, what will break this ionic compound, right? So ionic compound will not be soluble in the organic compounds like benzene or ether or chloroform. So we can understand why ionic compound breaks in water, or is soluble in water, and why it is not soluble in ionic compound, that is non-polar solvent. You can either write in the form of dielectric constant or solvation energy, but for examination I suggest you write in solvation energy form. Okay, write in this way, try to include this solvation energy concept over there, and you will get the full marks over there. Okay, if the solvation energy of that ion is greater than the lattice energy of that ion, then obviously it will be soluble, and if solvation energy is less than the lattice energy, it won't be soluble. So this is the solubility property of the ionic compound, and very important for your examination as well. Now let's see another property, that is the brittleness. For that, let me erase this portion. So this is the fifth and very important property of ionic compound, that is the brittleness. Brittleness is the property of an ionic compound to be broken down into smaller pieces by applying small amount of force. Okay, let me write it over here. Brittleness is the property of an ionic compound which allows it to be broken down into smaller pieces with small amount of force. Now if we see the lattice structure of ionic compound, then it is like this. There will be positive ion, let me draw it, positive ion, negative ion. Negative ion is generally larger in size. Then there will be positive ion, there will be negative ion, positive ion, and there will be negative ion. And this positive ion will be attached with a negative ion, and this negative ion will be attached with a positive ion. Similarly, there will be a negative ion and there will be a positive ion. There will be a negative ion and there will be a positive ion. It will be attached like this. There will be more such layers, but I am just making this one layer. This is actually they will be in a parallel layer. Okay, they will be in a parallel layer. There we can draw a line over here as well. Now this is the lattice structure. Now if we apply some force from here, this is my plus, this is minus, plus minus, plus minus, plus minus, plus minus, plus minus. Now if we apply some force from here, from this upside, on the upper layer of this lattice structure only, then what will happen? This will move little bit, and they are ions, and if we are applying some force by hammering it, then it will move. And if it moves, what will happen? There will be positive and positive, negative, negative, positive, positive, negative, negative, like this. Okay, I'm not making the whole structure. Positive and positive, negative and negative terminal will come closer. They will be together. That is the like terminal, like charges will come closer. And what happens when like charges come closer? They repel. They try to push each other far from each other. Okay, they try to push each other far from each other. Now, what will happen? They will eventually break. There will be plus minus plus minus plus minus, and there will be plus minus plus minus plus minus. You can see over here the bond is broken by applying some force. We have to apply force on some layer. They will move little bit and there will be a force of repulsion between the ions because like charges come together, and as a result of that the force of attraction between them breaks down and they will be separated. Now this is the property brittleness. So by brittleness property we can break down the given ionic compound into small pieces by applying some force or by hitting with a hammer. So this is very important property as well. Now similarly, another important property is, let me erase this portion for it. Okay, I hope you understood about the brittleness. Let me write another property, that is the rate of reaction. Rate of reaction. So rate of reaction. See, oh, look at here. The ionic compounds react very fast with anything. Okay, the ionic compounds are highly reactive. Let me write it. Ionic compounds are highly reactive. And if it is highly reactive, if the ionic compounds react very fast, then the rate of reaction cannot be calculated. So rate of reaction cannot be measured. Because the rate of reaction is measured only for slow reactions, and ionic compounds react very fast. So the rate of reaction cannot be measured. Similarly, another property is the density. And we know that the positive and negative ions are very close to each other in ionic compound. So there will be minimum volume, and minimum volume means maximum density. So density is very high. Density is high because density has the formula mass by volume. If the volume decreases, the density increases by this formula. So the ionic compounds are very dense compound. So these are the properties, different properties of ionic compound important for your examination. So in this video, we understood about ionic or electrovalent bond. We saw some factors that affects the formation of the ionic bond, and finally some properties of ionic compound. I hope you understood everything about this video. If you like the video, please share this video as much as you can, and thank you for watching the video.